Albrecht is an ACM fellow, and he has acted, for example, also as the chair of the SIGCHI conference, the biggest conference in our field. He's also a member of the ACM SIGCHI Academy, and we're very excited about the talk that he will give us today, where he's will argue that when we interact with AI, we are shaping experiences beyond just interfacing, but really are doing reality design when people interact with AI. So, Albrecht, take it away.
Thank you. Thank you for the kind introduction, and thanks for being here and listening to this talk. So, reality design, and I think this is something that dawned on me over the last years. I think I teach at university user interface design, and I think at some point I really realized it's much more than user interfaces. And I'll just start with a question. So think at your life. What part of your life is technology free? Where do you not have technology you interact with? And I think I just browsed through some of my pictures on my phone, and I share some of them, be it if you're in a club, if you're in the workplace, if you're in a museum, if you're in a workshop, if you're together with colleagues, even if you're in the kitchen. It is really, technology is everywhere. Whether you play games, you're in a lab, you run a conference, you drive a car, or you do outdoor sports. It is really this point that we don't live without technology. And there are very, very few places, and I think we have seen over the last 10 years quite some efforts in also looking how we can improve sleep, how we can improve the sleep experience. Also, there is technology. And so what I really think with technology being really ubiquitous in our life, we need to understand that when we design those technologies, we design people's lives. It's a bit like when you build a house or when you create clothes, you're really changing what people can do or what people cannot do. And I think this has become now part of our digital world. So really this question, what part of your reality is technology free? That's gone. Technology is everywhere. And for me, if I now think on a conceptual level, how does this look like? So we have the reality, and I think reality, I will not go in a detailed discussion because there are at most universities, there are whole courses on where people from typically philosophy will debate about reality. And I'm not going that fundamental. I'm taking a very pragmatic view what reality is. That's the stuff out there, what surrounds us. And then we are here as people. And what I find interesting now with technology, we can build something that takes on one side reality in and gives it to us on the other side. And also, if we interact with something, yeah, that could be also received by reality in a different way. And so from a mathematical precision, if you replace f by an identity function, you basically you interact with a world as you would have nothing in between. But very often we have by now a phone in between. And I think if we look at research, we very often think of glasses in between. And so if we have a hearing aid and reality has some sounds, we can amplify them. If we wear regular glasses, we see something, and there is a function applied to reality, and this gives us the reality. And I will come back to this picture quite a few times, because for us, really, this is sort of the overall view of the world. So we have the world, and now we have something in between. And as augmented reality becomes more viable in many situations, we can, with this function, shape how people experience reality. So looking at the talk today, I will talk a little bit about where we are and why this happens at this moment. And this looks at human memory, human perception, the bandwidth between humans and systems, also how we do cognitive offloading, and then what we see at the moment, a lot happening, new systems that also do knowledge synthesis. And then I take this and jump into the area of how interaction design, how the design of reality is changing. But let's take one step back. And I think in our community, superpowers have been a discussion point over the last 20 years. For many people, superpowers are in a way an inspiration, what humans want. So if you read fiction, if you watch fiction, superpowers are something that sort of, shows where we want to go. It really shows what the potential is. And if we look into fiction, we see there is physical superpowers, there is perceptual superpowers, and cognitive superpowers. And for us in the lab, especially the perception and cognition, those are the superpowers that are really interesting. And if you look back, superpowers like flying, that were a few hundred years back, people would have considered as a superpower, has become reality. Obviously not by ourselves usually, but we will use some machines around us. Also, perception has really changed. So seeing something that has happened an hour ago, 10 hours ago, is for us quite normal because somebody has taken a video and I can watch it. But from a perspective of the superpower, 200-300 years ago, this would have been a superpower, somebody who can look into sort of the history. Obviously, looking into the future is still one of those things which is tricky. And for us, those 5 points here, they have been resurfacing in different areas of prototypes we build. And so one of those things is enhancing senses. So we have human senses, but we have now sensors that can see more, can hear more. So we can create enhanced senses. Superhuman intelligence is one of these very generic ones. And I think at the moment, if you take people's access to internet away and let them program, that's a really interesting experience. So if you program yourself, if you have written software, just try at some point to write software without having access to the internet. We did this in a summer school at some point when we spent a few days on a mountain hut, and we realized none of us was very productive in writing code. And this was even pre-ChatGPT or Copilot, but you rely so much on the infrastructure. Precognition is another one, sounds like very fancy, but for a lot of things that you arrived this afternoon at 4:30 where you are and that you switched the computer on, that's in a way precognition. I was having dinner with a friend. I'm in Lugano at the moment. I've had dinner with a friend and I walked back to the flat where I'm staying and I came here in time to have a coffee because I knew Google Maps told me you will take 24 minutes if you walk back on foot. So I had sort of I could predict the future quite precisely. Enhancing perception of time. This is also something which is an interesting aspect. And telepathy is one. It's still probably a bit further out. But as we use the telephone or as we use now systems to have conversation across the globe, the question is, can we link this closer to our human brain? Can we link it closer to our perception? Can we really in the future create something which would feel like telepathy but is technically viable? So let's go step by step through some of the technological advances I find quite interesting in that context. So one is externalizing human memory, and there's a long tradition of externalizing human memory. And this was not undisputed. If you look 2,500 years back and you look at Greek writing, when this started, the top scientists at that time thought people will get really stupid if they write and read books because they will lose creativity. They will not remember things anymore. I think now we are much beyond writing. It is really hard to find a topic where you can not find things on the internet. Whether you want to change a tire, paint your fingernails or toenails, change a hard drive, do any other thing, there is so much knowledge, and knowledge here in quotation marks, out there, that if you are sort of a person who has some ability to access the internet and at the moment still reading and writing skills, there is very little tasks, real world tasks, that you cannot achieve because the information is out there. About 10 years back, we did the first trial towards extending human memory with sort of capturing everything. So this is sort of the question of live logging that's also over the last 15 years has developed much further. So what happens if we capture everything we see and hear and can outsource this? And we did quite a few experiments on this. What if you can go back in your life? And here, I think we see at the moment a big change happening. I think the classical live logging problem is you have recorded your life and you don't know what to do with it because you don't have a second life to look at it. But we are at the moment starting a project towards combining this with large language models, with multimodal models, to personalize them with your experiences. And so what we have seen, externalizing memory has made us really powerful in remembering things, and it has taken off cognitive load for remembering, which allowed us to be more creative. A second direction is really this altering human perception. So probably many of you have seen such high-speed camera pictures here, a bullet through crayons. And I think to do this, whoever has tried this is really a big effort. You have to get the lighting right, you have the cameras right. And for me, one of the questions was, can I build a system where I would have this as part of my classes, and if I just concentrate hard, I could slow down reality and see things. Again, sort of, we know these things from fictions, and we did this experimentally. So coming back to my picture from the beginning, the idea of what we built here is we have reality. Reality gives us a visual and auditory signature, and we put something in between. We sort of amplify some of the vision, we slow down things, we amplify sounds, and the whole thing, we want to control it implicitly, that we don't really say, I'm taking now a picture and I have to look at it, really that we do it in a way that it feels natural what we do. And one of the very early probes we did with this was directional hearing. So this looks very funny. It's basically a head and a directional microphone. This directional microphone is pretty good. It can listen into conversation 100, 200 meters away. And so what we built, a very technically very, very simple system. So you have your normal hearing, and you have bone conduction speakers on the ears where you can switch to the directional microphone, and then you can hear something that's far away. So imagine you're standing in a group, you see a bird about 100 meters away in the tree, and you want to listen to it. So you look at it, that's pointing the microphone. So by just looking, you implicitly point it. And then if you hold your breath, and you put your hand behind the ear, again, something you don't have to learn, you naturally do in listening, then we switch from your regular hearing to the directional microphone. And for us, this was something technically a hack that can be built in a few hours, but the experience you create for people was for us sort of this point that we really looked into how can we build such systems that give you sort of this other sense, and you can control it in a way, but you don't really realize that you control it because it feels completely normal. Another one where we looked into the sense of direction while swimming in the open water. Here's just a picture from the swimming pool where we did the trials. But in open water, your orientation is pretty bad. But I think if you just have two LEDs with different colors, you can create a guidance system. And again, sort of technically extremely simple, but it adds another sense. And coming back to the seeing we said earlier, so here that may be a bit small on your screen. So there is a bird that's flying off. And what we looked at, if there is something interesting happening in your field of vision that is fast, like a bird flapping, we slow down your vision. I think we built an initial prototype with a camera and a HoloLens, which was not really sort of from the experience very great, but we could demonstrate a thing. So there happened something like this bird is flapping and flying off. That takes a very short time. So basically everything happens between those two pictures. That's within a second it's gone. But the interesting part, how it starts, how it spreads the wings. So basically what we did is detecting this, we basically slowed down to slow motion, 1/10 of the speed, and then you can really see how the bird flies away. And then we speed it up again, reality, to catch up, because obviously the real reality has moved on much faster. And I think that was for us this idea, can I have something, if I concentrate on something, can I change it? And this feels magic in a way. And we had done some experiments by adding physiological sensing like EEG, especially on the head, to really guess intentions of the person and then do camera control. So again, not just the sensing is solved in a way, but what's really exciting, can you build a system which feels completely natural to the person, and the person doesn't really realize they're controlling a system. So far, we haven't really gotten to a point that technology is good enough that we could just build classes that do that. But the indications from our experiments we have says this will be feasible and we will be used to it. And I think if you wear glasses, you probably did not think of wearing glasses till this moment that I mentioned that you wear glasses. But obviously, you benefit from wearing the glasses. For me, if I take them off, the world is pretty blurry around me. So this question, can we build something that enhances our senses, but is so natural that it feels like an extension of ourselves? One more point in this technology space is the bandwidth between humans and technology. And if you think of your daily work, one of the questions is how fast can you read? And I think seeing that not everybody is asleep, I'm not sure if you can type something into the chat. I have the chat is going on here. So who knows their reading speed? What is your reading speed and what does it depend on? So how many words per minute can you read? Let's see if this works with the chat. I think it should work probably for everybody, right? Does somebody know their reading speed? It's one of the main factors if you are in research. It is really one of those main factors which impacts how fast you can do things. Yeah, I have to very often read dissertations, paper, and I think most of us have no idea. And I think it's in a way, it's really hard to pin it down. Because it really depends, and I think people say it here, typically it depends on the complexity of the text. If I give you a machine learning paper with a lot of equations in there, your reading speed goes massively down. If I give you a novel, which is very, very easy with very easy words, your reading speed goes up. But at the same time, if you look at your work time, the time you spend working per day, a lot of it is due to your reading speed. And so we looked into, can we optimize this channel? Because reading is a pretty fast channel, especially if you can read well. And obviously, most people we meet at university can read faster than they can listen to an audiobook. And so your reading speed, if you read 10% faster under the assumption you have the same comprehension, you obviously can outpace somebody who reads slower. And so what we looked here in this example is we did a special application on a watch, which is called RSVP. It's a rapid serial visual presentation. So you present the words in the same place. This allows you to read without having saccades. But here the tricky thing is, how fast do you present those words? And obviously, you can do this very simple. You basically do a reading test. You know you have 275 words per minute, and then you present it with that. but usually we get fatigue and things like this. We get different words that have a different complexity, longer words, etc. And so what we looked at, can we see from the EEG that people are in a flow state and keep them in a flow state? So basically we show the words as fast as possible to keep the person in the flow. And I think flow is something where this is, yeah, it's not boring, but it's not overloading ourselves. And so this is one of those things, if we think of bandwidth, one of those questions is how we provide enough information that we don't get bored, and how do we provide not too much? Because if we get too much, it's a bit like we are just watching things passing by and we don't comprehend. And here we think this combination of physiological sensing with the output side is quite powerful. A second one where we did some experimentation was what happens if you massively increase screen space. And again, here, what you see here, this is an experiment also a few years back where we had between 5 and 8 screens. And if you get a text like, be it a research paper or a set of research papers, and you have them on a complete screen, and you can, by walking forwards and backwards, you can never navigate. And by voice, you can highlight words. So basically, you look at this and say, okay, highlight the word, whatever, large screen, or highlight the word ChatGPT. Highlight, and then you're very quick as a human in sort of seeing stuff, taking a step forward, taking a step backwards. And again, this is something where our ability to navigate natural spaces in comparison to our ability to use a mouse to scan through documents is very different. So there are definitely things where having a small screen and scrolling through makes sense. But for many of these tasks where you try to get an overview, where you try to get insights, having all the documents you have in one place creates a really interesting and a stronger experience where you have a greater bandwidth to access knowledge. And I think just take one of the bigger conferences, which has, let's say you were at CHI, which is our big conference, and there are about 100 papers you're interested in out of the 1,000. Having all these 100 papers at the same time on display, and you can ask, okay, highlight me certain terms in all the papers, you're very quickly getting a different experience. You get a different access to the material. This is not replacing the reading, but it gives you a different trajectory, a different path into knowledge. And I think that's something which I think over the last years we haven't really seen much advances in increasing the bandwidth between systems and humans. We read a little bit faster on mobile devices nowadays, but it's probably not faster than on a high quality paper. We have sort of figured out a little bit of summarization with now large language models, but there's a lot of potential to increase this bandwidth. But it's really tricky because you want to increase, but at the same time, you do not want to lose quality in understanding. Moving on to the next one is easing cognitive tasks. And also here I have an example I start with from a study we did a few years back. So this was working with people with cognitive disabilities in a workplace. And obviously they are in a workplace where they do productive work because I think in most countries, people with disabilities have a right to work. So in the EU as well. And also I think it's, working is something which gives you achievements. And they usually build stuff for a car manufacturer, which we could not show. That's why you see the Lego. It's not that those people play Lego, but we recreated some of the tasks with Lego. And what you see on the picture is basically we have different complexities of things people build. And when you get highlighting, and it's a bit like extended pick by light, you see from which box to take things and where to put it. You basically have the same complexity whether you build 3 brick structures or 48 brick structures, because you always build just the next. And what we do here, we basically outsource the translation from a visual representation into an action. We basically shortcut this and say, okay, we detect what step we are in, we detect what is the next action, and we can then tell people what object you take and where to put it. And I think it's a bit like, I'm not sure if people use Thermomix for cooking. I myself, I'm not really a Thermomix person because I'm more an experimentalist. I build stuff, but there you get guided step by step. And so you take a lot of complexity out by guiding people step by step. And again, here we have a certain cognitive task. In our example here, the 2D to 3D planning, we take this out, tasks become easier. And I think also Pattie has worked a lot over the last, I think, nearly 20 years on sort of also this joint intelligence, cognitive outsourcing, I think. And we have here also an example, a student built was really in this space of interpersonal cognitive tasks. So I think one task is we look at other people, we know how to read them if we are sort of socially quite advanced. Some people don't know this well, and we explored sort of how can we build this, like detecting what the other person is, what conversations could I have, but we were not interested in that part because I think that has been quite studied a bit. We looked how can we put this into people's action. So basically, I have an idea what I could say to the other person, and that's fairly easy now. I do a recognition. I recognize something the person has in their hand, and I say, oh, you could talk about this. But what we figured, we have not really well established mechanisms or mechanisms that do not increase the cognitive load by adding this AI help. So if I'm at this point that I have detected what you could say to the other person, how do I convey this information to the person who is in this situation? And I think there's also, I think, early work, I think Seth Starner, also at MIT, had been walking around for, I think 2 decades with devices. And I think you could always tell when he was reading. And this is sort of something which we wanted to see here. And we did not really find a good solution how to get it. We looked into if you have sort of a speaker in your a headphone in your ear and you get told. Most people cannot deal with the cognitive load of getting the AI hints what they should do. Or if you put it in the visual field, people will just need some time, a few hundred milliseconds to orient and read. And this really breaks the flow of a natural interaction. So while it's interesting, we can have AI to create us or to provide us with ideas, what we can say, can provide us with information about the other person, about the mood, etc. At the moment, I think it's really an open question how we can convey this information without increasing the cognitive load of the person, without stressing the person. Because if you talk to a person and at the same time you hear in your headphones what you could say, you have to be very much trained to work with this. So there are journalists who are trained to do that, but it's sort of for most people, this really pushes the limits of cognitive load quite high. And the final one of those technologies is really this synthesis of knowledge, the creativity, the skill. And this goes now very much into what we've seen over the last 5 years, the idea that we can use models like language models or multimodal models to really have this augmented synthesis. And I will start with something which I found really interesting and in a way not surprising, but also very challenging. So there is a paper, I think it came out last year, which has somewhere in the abstract, human AI combinations perform significantly worse than the best of humans or the best of AI alone. And this basically puts in question the whole human AI interaction. I think also the whole idea of the of AHA, the series we're also here together. I think this is sort of this question. They have shown in a meta study that it's really sort of, yeah, the combination doesn't really work. If you read a bit further into the paper, it's much more differentiated. For certain things it works, for others it doesn't. But it's an important message to take away that it is not trivial. And very often it's assumed, oh, if I have a human performance and an AI performance, I combine them, it should get better. And I think just one point where it doesn't really work is if you have very rare interactions where the human needs to correct. We're usually not good at saying 99 times, oh yeah, that's fine, oh yeah, that's fine, and only 1 in 100 where we correct. Usually we want to correct more often. And I think that's something when we now create interfaces for this collaboration, if we in 99% or 95% of the cases are just agreeing with the system, we're probably not very good in doing that. And that's my interpretation why we see a lot of those interfaces failing. Going a bit further in this sort of collaboration, I think embodiment is another one that's quite interesting and where we need the synthesis of knowledge about the robot, about ourselves, and about the environment. And here we think that sort of the question is, how do we get the knowledge out of the person? And in this case, we try to build systems that motivate people to really provide that information. And this is sort of a robot that acts curious. So it acts as a curious, engaged student. And so what we then can see, if technology appears to be curious, willing to learn and able to learn, we're much more willing to teach it than not. Another one, and I think I'm not sure how many of you are working on a PhD or a master's thesis. I have here sort of in the middle of the talk sort of a hypothetical scenario. So I think sort of is sort of the audience, probably quite a few people are sort of probably writing up theses at some point. So imagine you have written 5 papers and published. That's your own research work. Probably across those 5 papers, you have cited 100 or more papers, and hopefully if you do good research, you also read them. And then there are probably 25 theses in your field that have been published over the last years, which you probably have looked at or where you read the related work. And there are probably 5 or so, at least from your own institution, which has the form. And you also have a red thread. Basically, the 5 publications you have, they give a direction of the red thread. And now you should write the first draft. And then how do we do the first draft? And obviously, after the first draft, you will go sentence by sentence. You will basically make it really, truly your thesis. And I think this is really tricky in a talk. Usually, I would have now the question, who would want to write the Python scripts to do that, to write the first draft, and who would basically enjoy more writing the first draft based on that? I think probably many of you can imagine how you would write the Python scripts to do that. That's very classical. You basically either build up a big context or you have retrieval augmented generation. So we can imagine to build, taking something long chain, Olama, building something together. So I think perhaps we can, because I think there's no tool that I can ask for a vote. I think you could basically put a software for, I would rather write a software into the chat, or you could write a W in there where you say, I would rather write it myself. Okay, that's interesting. So we have a few people who would write it by themselves. Both. That's interesting, and I think there's quite a few people who only would go for software. I think usually the more technical the audience is, the more often you get people who say, okay, I would write the software because I have the red thread. I know this sort of bullet points what I want, and I would just generate it and take it from there. So that's quite interesting that you would the self. And I think the self is something where you really learn a lot. But if you look from a utilitarian space, I think the generation, what you learn when writing the generator for this is quite interesting. And I think the interesting part is at this point, it's basically whether you write a thesis or you write a generator. But 2 or 3 years down the road, the PhD students will have the choice either to just upload those things, which I have mentioned here, and generate a draft. They don't even have to write the software. And there are even software products out there which do that. And I think it's really this question, do you value the intellectual exercise of writing your thesis, or are you utilitarian and you just need to get it done because your startup is lined up, your job at one of the big companies is lined up, or your professorship is lined up, and you just have to get it over with? And I think those are things once this discussion goes out into sort of more the private space, it becomes quite interesting in what way this turns. Yeah, thanks for the feedback on that one. So let's move to the next one. I think software engineering programming, we see a lot of these synthesis happening. And I think what I find interesting, and I think, again, being in a university environment, this is quite a point. So basically what we see is that in coding competition, there is a small set of really good people, good in the sense of writing really amazing software. And then there is a big set of people who don't really write very good software. And I think when AlphaCode came out, it was basically, okay, half the people who take part in the competitions are worse, the other half are better. Now and I'm not really sure about the 87, but I think there are also other people have reported 80. So basically, now with AlphaCode 2, basically, if you belong to the 20% best developers, your job is quite safe and people will probably pay you a lot of money. If you belong to the 80% developers who are not in the top 20, your job is probably gone. And I think that's also an interesting point. So, and that's not just for coding, it's for many other areas as well. So where does this lead us? Do we only need sort of the people with the top cognitive skills and the others do something else? Or does it really make sense to have more people who have those cognitive skills? And also, will those cognitive skills change? And I think we look at the moment at something where we especially look how human-centered specification could be used. And it basically goes beyond vibe coding. It's really the idea you interactively create a fairly big document, and based on this document, you generate the code. So you really write a specification that may be 10, 20, 30 pages long, depending on how complex your application is. And if you have forgotten things in your specification, so for example, if you said, oh, you did not specify how people log on, the interactive software would ask you, do you really not want to have a login, or do you want to have a single sign-on you want to include? Or if you have not mentioned a color scheme, it would come back. So the idea that you interactively create a specification document, which then can be translated into an executable. And this is sort of a space where we probably see something which goes beyond programming languages and goes into a new space in that sense. So co-creation is one of those big topics I think a lot of people do research at the moment. We had something for co-creation in a museum, and we let people co-create with a language model and a image generation model, but we were not much interested in what people created. We were interested in how people signed it, who they attributed authorship. And it was also quite interesting that half of the people think themselves of the author, and the other half is then split between, oh, it was just the AI, or it was the AI and me. And I think we have, as communities, we have defined AI cannot be an author. But it's interesting when we look now at the practice, a lot of people feel that the AI is an author. Perhaps we have to rethink these aspects. Now I want to wrap up with rethinking how we do interaction design. And I think there the first big question is, what cognitive tasks can you as an individual do better than an AI? And then you could also ask, what cognitive tasks can 50% of the population do better than an AI? And then it becomes quite tricky. And we do sometimes this sort of conceptual experiment. Imagine you have a very highly educated person without access to technology, and then you have a 14-year-old kid with access to the internet and to large language models. Which questions can you answer that would be answered faster, better by one or the other? And usually when we ask this question, it's very quickly, we find a lot of questions we can ask where the kid is massively faster. Very often it's really hard to find concrete question you can ask somebody which they have, if they don't have internet access, where they are better. So this is usually quite very person specific. But underlying to this is quite the question, the person with internet access is also always a person without internet access if they choose not to use the internet. So the question for me that goes beyond this is, how do we understand when to think ourselves, and when do we want an AI to think for us, and when do we want to co-think with an AI? And to me, the research is very sketchy at this point. I think we have not really understand when do we want to think ourselves, and when do you want to have the AI do it for us. And I think a lot of the tests we see at the moment seem a bit like this: is a car faster than a human? And that's a fairly pointless question, because obviously a car is faster than a human, but it's not really a reasonable question. Humans still walk, humans still compete in running. And this question, what are humans better at? What are machines better at? This is really very, very old. So a lot of you probably know Fitts' law from human-computer interaction, but also around that time in the 50s of the last century, there was this push for automation, and there was the idea, where are humans better than machines, and where are machines better than humans? And I think this question is not going away, and the question is not only from a utilitarian perspective. So the old paper here, the Haba Maba, is very much utilitarian. But nowadays also what we need to add, where do we think as humans we add the value by doing it by a human rather than doing by a machine? And I think we can plot this as a two-dimensional grid where we say we have things on one axis, how difficult are they for a machine or for an AI to do? And then we have on the other axis, how difficult are they for a human to do? And there are things that are easy for machines and easy for humans. So doing basic arithmetic calculations are really easy for machines, and they're really easy for humans. And then we have things where they're not possible for humans, and we have no known solution for a machine. And that's a perfect prediction of the future. And now is the question, where are the interesting spots in this matrix? And I think the interesting spots in a way is things that are easy for machines or even hard for a machine where there is no possibility for a human to do it. And I think things like searching in a database is this easy for a machine, impossible for a human in finite time. And I find this very simple matrix quite helpful to discuss problem spaces that are interesting and that are interesting for research. Very often it says, oh, for easy for humans and hard for machines is creativity. This is sort of in that space. And I would sort of be careful with this on the creativity side. Is creativity really the one thing humans are better than machines? And I'm doubtful in a way. And there are some quotes that in my practice link very well to what we do with LLMs or also with creating pictures with Midjourney. So creativity is seeing what others see and thinking what no one else ever thought. It's attributed to Albert Einstein. We don't know really if he said it, but I think that's one practice we see with AI. I create a lot of things. So for example, I write a research proposal and I create 30 research questions and 29 of them are stupid, but some of them are really interesting. And I have the ability to spot the ones that are really good. And that's basically, that's creativity according to this definition. And I think there the humans have something. Similarly, if we look at what Pablo Picasso said, he said, art is the elimination of the unnecessary, and good artists copy, great artists steal. That also links to a lot of things. So I let generate a lot of research questions, or I generate a lot of pictures and I pick what I want. So I'm really good at sort of eliminating, I see what's not fitting. And I think that may be one of the human skills where we have the judgment and we are very good at doing that. But there's also quite the opposite discussion that you say, oh, yeah, people are not necessarily good at these creative steps. But I think generally the creativity is quite a complex topic, and I would see sort of amplified creativity or augmented creativity as really an interesting space. But at the same time, I think the knowledge you have to have in order to act as this filter, as this person choosing the right thing, is quite a big investment. One short notice on, I think we see at the moment a lot of benchmarks, and we see them also in our communities. So people provide a benchmark data set where they have questions and answers, and then we can read Llama 3 point whatever is better than Mistral, or ChatGPT is better than whatever other model at this point. And I think this is really, in a way, it doesn't make much sense, because what we see, these test protocols, they're really easy to do, and they're very similar to what we see in machine learning. But there is no human involvement in this benchmarking. And hence, I think they're not useful for human-centered AI. And I think we have seen a lot of those things since the beginning of ChatGPT, where we had, it passes the bar exam, it goes up. It has all these questions. But I think what's missing at this point is, how do we make this a human-centered AI benchmark? How can we really include human ingenuity into sort of benchmarks? And so far, I haven't really seen much on that. And I think that's also in our lab one of the questions. What would be a good benchmark that really measures human AI performance and not the AI performance on questions typically posed to humans? On coming back to the design side, is we looked at what happens really to the whole design, the human-centered design process. And we wrote sometime back a short article mainly asking questions about, do we really need to get the humans still involved in these processes? And my take is yes, but not for everything. And similar it will be with these benchmarks. We have to really understand where we want to involve humans in order to make this this work. And yeah, I want to wrap up with coming back to writing. And yeah, one of the terms we use now a lot is rethink thinking. And this is a quote nearly 2,500 years old. For this invention will produce forgetfulness in the minds, will discourage the use of their own memory. They are not wise, but only appear wise. And I think you could basically put this forward. And I think if you look into popular press of the last 3 years, we have seen this a lot for the use of large language models. But this was about writing, and there was a big worry that writing makes people stupid. But what we have seen is, in contrast, writing really changed the world. And now the question is, what is this powerful part of writing, and how can we translate this to AI? I give you one simple example. So dividing those numbers, everybody can do, because we can outsource memory through writing. And so basically, once writing was invented, this was not there. But then people, once they could write, they created mechanisms to think things they could not think before, because they were able to outsource that. Or when you make a paper, you write a mind map, or hear the calculations, or you make notes during a talk, or you make notes and then rewrite things. These are ways that could not have happened without writing. So when writing was invented, we reinvented thinking. And I think now we are at a point where we have to reinvent thinking again. And I think with this, I come to the last part. So the future reality is largely designed by people. And there is this quote, I think a lot of people have used that, again, sort of said, it's from Winston Churchill: we shape our buildings, thereafter they shape us. And I think what I really think nowadays, we shape our digital realities, and thereafter they shape us. And we can shorten it a little bit, because as I said at the beginning, the digital realities are our reality. There is no difference between the digital. And it's, I think, the big question: who shapes those realities? Is it sort of the companies who build the models? Is it us who use models? Is it people who create new models? So really this question, what is the we in this this space? And with this, I come back to this very final final slide, which I had also at the beginning. I think it's really for us an interesting question to think, what is reality in this context, where reality is only seen through the lens of a function which can alter the input and the output. I talked today more on the input side, how we change how we see things, how we change, but obviously with robotic, with exoskeletons, etc., we can also go into the other direction, creating reality. And obviously a lot of the work we do requires money to pay people, pay equipment, and we have quite a lot of funding agencies that are helping us. And I think with this, I'm not sure if we have still time for 1 or 2 minutes of questions.
If you are available, Albrecht, I think it would be great if we have another 10 minutes. I know it's late in Europe. My apologies.
No, I think I'm waiting still for a colleague who was supposed to fly in, but he is delayed. So he's not coming before midnight.
And while people are writing some questions in the chat, I had a question/comment. You presented a matrix for who should do what tasks should we delegate to AI versus doing them ourselves. And you proposed that the main sort of criterion is whether it's difficult for one or for the other, basically. But I would argue that difficulty is not a sufficient criterion to think about when you are making that decision, because it's not just about accomplishing the task. it's also about what other side effects are there of accomplishing that task. For example, we have had calculators since whenever, the 50s or something. We still teach kids arithmetic because it's important that they internalize that skill. It enables them to understand the news and the economy and markets, and there are all sorts of things in their daily life. You can't always, it allows them to make analogies and to understand other fields in terms of like what mathematical phenomena they may see there and so on. So I would argue that we shouldn't just think about what is hard or not for a human or for AI, but that we should also think about what else do you lose by not doing that task yourself? And if it's important that you learn a particular task, then maybe you should not just hand that over or delegate that to AI.
Yeah, I think that's a really interesting point. I think that's at the core. I think what do we really want to think ourselves? And where do we, and I think it's on the one side, what do I enjoy doing? Do I enjoy writing? And as a scientist, I enjoy experimenting, I enjoy writing. Do I want to have this taken away from me, even if I'm not as fast as the AI or not? Or creating that draft for a dissertation, I think it was quite positive to see that a lot of people say, oh yeah, it's probably where I synthesized the last 5 or 6 or 7 years of my life, and I don't want to give this to somebody else, even so if I could. I think this is, I think, very fundamental. And I just opened one slide where we have at the moment a lot of discussion about and I think this is something the world has basically gone from 10% literacy to something like 80% literacy. And now basically I have 2 potential futures for the next 100 years. This is one future. Basically, we stay at this literacy level. Perhaps we go even a bit up, or we go down. And for me, I'm not sure which one I believe. I'm sort of obviously sort of as somebody who likes reading. I think this would be sort of obviously what we should aim for. We still should have people to be able to read and write. But looking at some of the other trends we have seen, and it may be going this way that reading and writing is just for the intellectuals, because yeah, you can generate text as sort of a underlying code. You can always have it read out and you can speak it and put it in. But we know that, for example, writing or creating text, thinking about things requires writing. So I'm not sure basically where we go. And I think this is one of those questions also where I think we need a societal discussion.
Yeah.
What are the essentials we want to have? And I think for me, writing would be one of those essentials. Yeah. Reading would be one of those essentials. But seeing literacy skills at kids at the age of 12 in a lot of developed countries is sometimes quite frustrating if you look into the data. And so we see it with foreign language learning. I think that's something where, especially in Europe, there's a lot of discussion. In order to understand different cultures, you should speak a few languages in order to get this. And I think that goes all the way. If a language doesn't have words for something, you cannot even train a machine learning algorithm. Basically, if you have the machine learning algorithm turns out English words, but there is something in the picture where there is no English word for it, you cannot even recognize it. And so this question about language learning when we have automated translation. But I think this goes much beyond the technical realm. And I think we need a societal discussion. What is sort of this common stuff? And I think I've got one slide. What do I really find scary about AI? And I think for me, the biggest risk is really that people lose the motivation to learn and think for themselves. Mm-hmm. That become very utilitarian and lazy in a way. And obviously we are made in a way that we are lazy because it conserves energy from a biological point of view. But I think at the same time, if we are not pushing ourselves to limits, and be it physical, like walking up the mountain, or cognitive solving a hard equation, we are obviously losing out on certain skills. But I think this is sort of, it's a very complex issue.
Yeah, indeed. I think we need a discussion about what should humans still learn also, because we risk not learning when you're not involved in solving a problem or performing a task, then you don't learn in the process. So maybe right now we can have senior computer programmers who are very effective at using AI because they actually know programming and they can actually understand what the system ultimately outputs. But what if nobody learns programming anymore? What do we risk losing then? And can people who never learn to program, can they really effectively work with an AI that helps them code? And can they really produce software together that you can totally rely on and that you feel can operate a nuclear power plant, whatever?
That's a really, we have done some studies on that. Obviously, currently, people who can write good code without, they benefit maximum from these tools. They benefit a lot because they know, and we had sort of a quote from one of the developers. He said, oh, after I tried 2 or 3 prompts, I got exactly the code how I would have written it. And I think that was for us one of those, and obviously you have to be very good. But then I think to put sort of a bit sort of the other thing, when I started university, I did not do much assembly programming. And I had sort of old professors who basically said, oh, if people don't know machine language and they just use C, they have no idea what happens underneath. They will write awful code. And now there's a whole generation who doesn't even program C, who are sort of, so I think it's a question, what is the next level abstraction? And that's why I'm quite excited about this specification-based software development. So do we find another abstraction layer? And I think computer science has been really good in finding these abstraction layers. So I think it's again sort of, it's an open research topic, and I think something to probably over the next years we'll find out where are the boundaries, and that's why I find this topic at the moment so exciting.
It is, that's for sure. I see lots of comments in the chat, and not directly maybe, well, there are some questions as well. A lot of people are bringing up sort of the importance of personal agency in thinking. For example, the comment here by Jules Park. People also bring up Neil Postman's writing, which I have on my to-do list for reading again, because he argues, of course, well, before AI existed, but for other media, sort of how it affects how we communicate, how we think, the whole fabric of our society. So definitely highly recommended reading for everyone. But yeah, let's take maybe Jules Park's question. So it is becoming more clear that human-AI collaboration will grow as a research field in need of new interaction paradigms. One concern that I have is that we may lose some level of our personal agency in thought when engaging with these interfaces as we optimize our ideas. How important do you see personal agency in thinking? Do you think it's inevitable? And what is a better question we could ask as future designers, builders, researchers, etc.?
I think agency or control, I think there are different terms people use at the moment, is the key. And the question is how to achieve this and at what level. So we very often discuss this question of granularity of agency. So if for example, if you drive an autonomous or a car that's navigating, what level of autonomy do you give to the car, and what agency can you exercise? Is when you park, is there a value that you can park sort of 7 centimeters from the line or 9 centimeters from the line? or is basically the decision which parking spot to use, is this relevant for your agency? And I think one of the questions is that we figure out for what things we can make a contribution that's valuable for us, where our agency adds value for us, not utilitarian for the system, where it gives the agency, when I exercise the agency, I get value for me, and not having agency for agency's sake. I think that's one of those things we see a lot also now. If you look at the GDPR, the European data, there's a lot of things where you feel there is quite some stuff in there which is not necessarily, basically it makes things complicated. There's a lot of good stuff, but also stuff that's complicated. So I think really understanding the agency as a mechanism to empower me as an individual. And also, I think it's not just the individual. I've recently toyed with the terms. I think we use a lot of human-centered AI now in a lot of writing. And I think the question is, should we use humanity-centered AI, sort of where we go into the plural, which is basically also taking the societal aspect into. And I think we have seen in social networks, basically targeting it to the individual can have massive bad effects on society. So I think this question, human-centered, basically agency of the individual versus collective agency on it. So it adds another level. But I think that the short answer is that's a topic I'm really interested in. And we are at the moment, we got now some funding from the European Union to really investigate what it would mean to have a truly personal model that is really based on my human experiences, that builds based on what I have experienced and recorded for myself, and which I don't have to share with anyone else, so that I can have and we call it AI twin, sort of this system that has my experience. And there our hope is that we can get agency which is not annoying. I think this question is, if you have control agency and you have it on a very fine granular level, you may overwhelm people and people say, I don't care. And I think we have this big example in Europe. I think whenever you go to Europe and you browse the web, each time you open a web page, there pops something up, do you want to have cookies? And it's really for each web page and that was mandated by the European Union in sort of the idea that you have to, what happened to it? And I think there's now quite a number of studies. People open a web page and whatever comes, they click OK because they know I needed cookies, otherwise it doesn't work. So basically having agency in a way that we really can use it for ourselves and that we get empowered by having it, rather than having it as a design goal, which we have to put in. So really understand where it is good and where it isn't.
Well, I think we have to end there because we are kind of over time, but you left us lots of things to think about, and we can continue these discussions later, hopefully. If anyone is interested in the recording of this seminar, previous seminars, go to the link that I just put in the chat. You can also find information there about a workshop that we are organizing in October to come up with benchmarks for human AI interaction, or new benchmarks that we could come up with to evaluate AI models to what extent they really sort of enable human flourishing specifically. So please check out our website, and let's thank our speaker, Albrecht, again. Thank you. Great talk.
Thank you. Thank you.
Thank you.
Bye-bye, everyone.